Let's take a look at the OR cases. And how would we be able to recognize the OR cases? Always looking at once your absolute value is isolated, you'll see that you'll have a greater than symbol when compared to your constant. So that's telling you we're looking for OR. So if we look at example 12, or any example, what I'd like to do, remember the first thing we always do before we start is always isolate the absolute value first. That's really big. So that would mean we subtract 7 on both sides. We would get the absolute value of 2x plus 1 is greater than or equal to 5. The next thing we double check for ourselves is kind of just as a heads up, understand that we do have a positive number. So we are good to go as far as the cases. We don't have to think anything that might be special. So just so that we're clear, we do see the greater than or equal to symbol, and it is compared to the constant positive 5. This is going to remind us that we do have an OR case. So when we do split up into the two cases, case 1, it's kind of the same thing. We would say, okay, 2x plus 1, we drop the bars, keep everything the same, greater than or equal to 5. Don't forget the link word though, that's important. Or case 2, drop the bars, reverse the direction of the inequality symbol, and change the sign of the number. So positive 5 became negative 5. And now we'll solve each inequality by isolating x. So we can subtract 1 from both sides. We get 2x is greater than or equal to 4. Divide by 2 on both sides. X is greater than or equal to 2. Subtract 1 on the next inequality from both sides. 2x less than or equal to negative 6. Divide by 2 on both sides. X less than or equal to negative 3. Don't forget, link word is OR. Now if we take the time and we graph, remember when you graph on the number line, what you'd like to do is just plot the numbers in relation to each other at one point. So I'm kind of seeing that the negative 3 would be to the left of the 2. And then try to understand which way you're shading for each of them. So x is greater than or equal to 2 means I'm shading to the right of 2, numbers that are bigger than 2. Greater than or equal to would mean I have a bracket. And x is less than or equal to negative 3. We would be shading to the left of the 3 with another bracket, facing always the way we shade. And let me make sure I write that negative in there. Sometimes if we're not writing clear, we forget to write it in our solution. And now our job is to figure out what are we taking for the solution. Because we have OR, we don't have to modify our graph. OR means union. And union means take whatever we have shaded. So everything that you have shaded is your solution. So if that is the case, we're just going to describe everything that we've colored. So in our case, the solution, and I'm going to write an interval notation because that's my choice. They didn't tell me otherwise. If I'm describing the green part, I would be coming from negative infinity, stopping at negative 3. And we have a gap. And so when we want to talk about a gap, we would say we have a union. We want to start up again at 2 and go all the way out to positive infinity with a bracket on the 2. And there's no other way to do these ones. Whenever you have OR, you've got to think about what your solutions will be. No shortcuts here. That's why I kind of go with the graph method. It really does help.